Welcome to my presentation. In this presentation, we shall look at the procedure related to perfect square trinomials. A perfect square trinomial is a square of a binomial, isn't it? Let me write that and I will explain that a little bit more. A perfect square trinomial perfect square trinomial is the square of a binomial. The square of a binomial. Square of a binomial. How is that? Let me explain that. If A and B are real numbers or variables or algebraic expressions, then I can write this as A plus B, the whole squared, as equal to A plus B times A plus B. I can also write this as A squared plus 2AB plus B squared. Okay, that is one formula. The second formula is if A and B are real numbers or variables or algebraic expressions, then A minus B, the whole squared, we can write this one as A minus B times A minus B, and that we can expand it as A squared minus 2AB plus B squared. Therefore, going back to the explanation which I gave, a perfect square trinomial is a square of a binomial. A perfect square trinomial, this one here, this expression here is a trinomial. This expression here is a trinomial. A perfect square trinomial is a square of a binomial. This is a square of a binomial. This is a square of a binomial, and that is exactly what we've been talking about. And then these formulas, they are not some arbitrary formulas. We can prove them. We can just take those formulas and then be able to use the distribution property and be able to arrive at those things. Okay, so let us try that. If I were to take A plus B, the whole squared, and if we said that is equal to A squared plus 2AB plus B squared, let us prove that. We'll take the left, we will call this one as the left hand side of the expression, and then we will try to show that when we expand this, we're going to get the expression what we have on the right hand side of the expression. So A plus B to the power of 2, I can write this one as A plus B times A plus B, and I can use the FOIL method. The FOIL method is we're going to multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last terms. Pretty much we're using the distribution property here to be able to expand it out and then combine the like terms. When we expand this, we're going to get a trinomial, and that is we will see what that trinomial is going to be. A times A is multiplying the first terms plus A times B if we are multiplying the outer terms, then B times A we are multiplying the inner terms, and then B times B we are multiplying the last terms. When we simplify this, this is A squared. A times B is AB. B times A or A times B means the same thing, so therefore I'm going to write it as AB, plus B times B is B to the power of 2. So therefore when we put all of this together, A squared plus AB is 2AB plus B squared. Therefore, A plus B, the whole squared, is equal to A squared plus 2AB plus B squared. That is the way we want to understand this trinomial or this binomial raised to the power of 2. Similarly, we can also show that A minus B, let's show this, A minus B, the whole squared, is going to be equal to A squared minus 2AB plus b squared. And if we say this is the left hand side of the expression, we'll take the left hand side of the expression and expand it out and then see whether we get the trinomial on the right hand side. A minus b the whole squared I can write as a minus b times a minus b, like that. And therefore, if I use the FOIL method like what we did in for the a plus b to the power of 2 formula, we can expand this one using the FOIL method, and we are pretty much using the distribution method here. And therefore, we're going to multiply the first terms, a times a, multiply the outer terms, a times negative b, then multiply the inner terms, minus b times a, this is the inner terms, and then multiply the last terms, negative b times negative b. So this is the last term. When we multiply this is going to be a squared minus ab, a times negative b is minus ab, negative b times a is negative ba, or negative ab means the same thing, and then negative b times negative b is positive b to the power of 2. Therefore, we can combine all of this as a squared minus ab plus minus ab is minus 2ab plus b squared. And therefore, a minus b, the whole squared, is going to be equal to a squared minus 2ab plus b squared, and that is what we wrote in the beginning of this presentation. And this is the way we want to use these perfect square trinomials to solve some example problems. So therefore, a perfect square trinomial is the square of a binomial. Okay, so we will use this procedure to solve some simple example problems in my next presentation.